Please subscribe the
Hello
channel.
everyone. In our series today topic is what is correlation. So this is the definition. It is statistical measure that define the relationship between two variables. The two variables are linked with each other. It describes the effect of change in one variable to another value. It means that if we have two variable and we change the one value to another one value in one variable, so it effect to the other variable. uh, in two variable are increase or decrease in parallel, then they have a positive correlation between them, and if one variable is increase and another is decrease, then they are the negative correlation with each other. If the change is one variable has no effect on other variable, then have a zero correlation between them. It means that if I change the two variable, I have two variable, and I change the value both of them, that in parallel way, that it means it give the positive value. If I change only one variable and not change to other, so it give the negative values. um, and some it is said that correlation are two types. Some says that this is the method, yeah, this is the types of correlation. Pearson is a parametric correlation, and Spearman in non-parametric correlation. The definition of both of them, Pearson means parametric. You can say the parametric correlation. Pearson correlation is used to show the linear relationship between two variables. Pearson correlation returns the -1 or 1 with the one meaningful positive correlation and -1 full negative correlation. It means that if we have relationship and the output is the -1, it means the positive, and if give the one, that it means the is an sorry, if the output in two variable, if one variable give the minus, so it means negative correlation. If they give the only one, then it means that we have the positive relationship. In Spearman, non-parametric parametric means Spearman correlation is non-parametric version in Pearson correlation. It is used when relationship between two variable are non-linear. For example, relationship that sometimes strong and sometimes weak depend on the data. It means that a non-linear relationship, it depend on the we know the linear relationship, that one is independent variable and other is independent variable, is called the linear relationship, where is only one x and one y. And non-linear relationship, where we the first value sometime that it show the strong output, positive output, and sometimes it show the negative value, that it means that it is a non-parametric relationship. So now let's move to the practically. I show you it practically, so I clear it. Then first we install the library. Is a ggplot2. Is first you install this library, you go to the install, then package, then install, and then you type the library ggplot2. This one is ggplot2, and clicking on the install. I have already, this is the data. um, uh, it's working. This is the data. is a lamp body weight. This data set I will provide you in description box, so you can download it. So we run. There is a only two variable, BWT and WT120. Now this is show the structure type of data. Is a numeric or string. Both are the numeric values. Now I want to create the box plot. So this is the box plot where is the BWT has very less correlation, and WT is a 120 has much. Now we mostly correlation we use the scatter plot. This is the scatter plot that DF BTW. There is a point value is showing on the point 4.0, and where then WT 120 where is V is a 25. Now this is the correlation. We want to see the both variable correlation. So it show the 18 17 80 78972. Above now next is I want to see only the person person correlation. So this is the variable COR, and DF is my variable name, is data set name, where I pass that. If you write down the dollar sign, if you, then it automatically give the both variable name, so you have choose the which you want to first. So these are the both variable name and method. There is I also pass the method is only person. So there the output is the same, is a is a show the same. Now next is I same here. This is the parametric relationship, and now I want to non-parametric. Yeah, it mean spearman. The other name also the spearman. So same method I am using there. Is a variable, and DF is data set name, and their dollar sign, and then pass the value, and method is equal to spearman. Then run. So it's give the 0.816. This experiment have the different relationship. Now next we also use the different using the different types of library. We want to show you that we can use correlation using the different types of libraries. So these are the core plot library. So if you do not install the package, so you can install first it, install dot package, then you can write the name core plot. Or it's a better method is go to the package, then package you will then install. Okay, the next is library. I'm running, the library is working. This is the they show, because they show the core plot. Core plot is a inbuilt function where I pass the core is a name, uh, variable name where I pass this, and DF is my data set name. Okay, where I pass the method is equal to number. If I pass, there is different types, so we can use. If I pass the number, so it show the BWT has 1.0, and WT 120 has the 0.11 and 1.0. There is a this one is a relationship. So if I give the circle, So it shows you circle. You can also use there is square, 2 3 method you can use. And type is equal to upper because uppercase, the name is on the uppercase. Okay, the next, I want to test the correlation between the both variable. So this is give the this value data is a t is equal to, and df is 119, and p value is probability, just probability value is 2.2 e, and these are the percentage confidence intervals and all this correlation. This now next, I am using the library corporate. This one is a correlation. So run this library, and this is the correlation is correlation and colon sign, both are the colon sign and correlation. Then there I pass the data set name and include factor. This is the inbuilt function, is it true, and method is equal auto. So we run the, it shows the parameter 1 and parameter 2. This is the parameter 1 is the first variable, then second variable, then this is the result, and there is the, just give the value, both first value and then second value, then is the next, and this is the probability values. So this is the program of the correlation. uh, hope hope you like it. Thank
Thanks for watching.